In this video, we'll go over an example of multiple linear regression, and we'll use the home market value example. In this particular example, we're trying to predict the market value of homes based on the house age and square footage of the home. The market value has two variables, the original market value and the market values in thousands, so we'll just use the one in thousands. You have the data set here as a data file. It's a CSV file, so what I'm asking you to do is just to go ahead and download it, and you'll be able to use it right away. You can use this example in RStudio, or you can also open in Collab. And to illustrate this, I'm just going to go ahead and right click on the open in Collab, and this will open up the Google Collab page with the example. If you're logged in to your account in Google, this should open up right away, but if you're not, then it will prompt you to sign in. To run the sample, you just need to have the CSV file loaded to Google Colab, and to do that, you can right click on the files here. You can click on the files here and then upload. To upload, I'm just gonna go ahead and look for the file. You can also link your Google Drive here, and that will prompt you to just get the file right there. But just to make it easier for you, you can just go ahead and try to find the market values example file where you download it. So for example, I have it in my downloads, so I'm just gonna look for it, and I am going to just try to search it. And you can see that, let's see, market values. I have that CSV file right here. And this is what you get. You have the address, the house age, the square footage, the market values in thousands. So just to load it to Google Colab, all you have to do is just to drag and drop it there. Okay, so I have because I have downloaded and I wanted to illustrate it to you this way, you have this market value data, and then in parentheses you might have a 1 just because you downloaded it before. So that might be the source of errors if you have a name that is different. So what I would recommend you to do, and this also happens to be the same in RStudio, is to just go ahead and take a look at the path of the file. So one thing you can do here is just to, instead of having market values data.csv, you can copy this name exactly, or you can just say copy path if you're in Google Colab, and then paste it there. So that makes sure that you have exactly the same name. So I'm just gonna run that, and to run that I can click here, and it will prompt me to just go ahead and run. And when you run, you will see this check mark stating that it's been already run. So you have the read.csv file, and all you need right now is just this. Generally, I would ask you later to use always the strings as factors is equal to true, so that you can read files that are categorical as a factor, and it will make your life a lot easier when we just go ahead and refactor variables so that they are coded correctly when you're doing regression. So I'm just going to go ahead and close this so that you can have more space. Having the variables here, you can see the address, house age, square footage, and then two y variables. It's for you to decide which one to use. Like I mentioned before, we're going to use the one in thousands. So the first thing to do might be just to plot the data And in plotting the data, you might have, what you have is the X variable first and the Y variable. After that, if you want to plot a scatter plot of a single predictor square footage against the response, I have used the X label is equal to square feet here, so that you can show these square feet, and then the Y label market value in thousands. You can put some Y limits just so that it goes from 200 to 300, and you can change that around if you want to. The appline function basically plots a regression line, so you can see this here. So I'm just gonna do the lm function just to get that regression. So market value in thousands is the Y, and then square footage is the X, and then that's the data, MV data, how we named it when we read it. Just to put a color red, and I'm going to run that. To run it, you can click here, or you can just do Shift Enter, and that would do the same thing. You can see that there's a positive relationship, and it looks fairly linear. Some couple of points might be far away from the line, and that's that's an indication that for example, this home with about 1,600 square feet is priced a little higher than what you would expect. So having said that, like I said, you can change this code around. If you're in Google Collab or if you're in RStudio, you can just basically change these values around so you can see it better. For example, I can change these to start at 220, and you can see how different it looks. You can go up to 280. If you want a graph that is contains the values a little bit more tightly. So it's always up to you to modify the code so that you can see how it's working. The scatter plot of we have this first predictor square footage, and then we want to see the house age, how it looks like. So I'm gonna run the code. It's exactly the same, only that I'm using house age as a predictor, and the Y limits stay the same, so I can run that. And you can see that it's also positive. So in other words, the house age and the square footage both are positively related to the market value. That makes sense. Something else that you can do, and just to illustrate this to you, I'm going to add another cell, code cell, and in this code cell I'm going to just use the plot function on the whole data set. And what that does is that creates a scatter plot matrix with everything that is on the data set MV data. Now, this might not be the best way to do it because you have address here, you have market value and market value in thousands. So you might not get just the house age, square feet, and market value in thousands that you need. But let me just illustrate this to you and run it so you can see what a scatter plot matrix looks like. So you can see every single predictor and all variables. Just to show this to you a little better, let me just blow this up. You can see that there is a relationship between all the variables. So you can see, for example, let's say if you wanted to look at the relationship between market value in thousands and let's say house age, and what you would look at is this row for market value in thousands and then house age, which is what we saw before, and market value in thousands with square footage, and you can see these here. But you can also see the relationship between square footage and house age here or here as well. So that allows you to, basically, see all relationships at the same time. So if you want to basically make this a more informative plot, you can always do subsetting. And in subsetting, you can just select the variables, like you've seen before in R. you can have this MV data, and you can use the subset function to just subset the variables that you want. Or you can also do the brackets here and just select just to select either rows or columns. In this case, we're gonna select columns. So I'm gonna use the C function to just concatenate the columns that I want. In this case, I don't want address, the first column, so I'm gonna ignore that. I want column number 2 for house age, column number 3 for square footage, and then column number 5 for market values. Okay, so in this case, this would get me the the one I want, the scatter plot matrix I want on this. So again, you can see the relationships here with market value in thousands, but you can also see the relationship among the predictors themselves.